Assalamu alaikum, sir. Welcome to the presentation. The Group 1 is here to present the presentation. I am Obaidullah on behalf of Group 1 going to present the presentation. The slide shows the Group 1 members. Let's go to the next slide. Our assignment on 8:1 marks by using 4:1 marks. The topic covers multiplexer, 4:1 multiplexer, 8:1 multiplexer. Let's go to the next slide. Welcome to the new slide. The slide title is multiplexer. First of all, we have to know the multiplexer. Multiplexer is called a MUX in simply. So a MUX is a digital switch that has multiple inputs and a single output. It is not matter that what is the number of inputs. It is matter that the number of output will be always one. Uh, in a multiplexer, there are data inputs, but there are a special type of input that is called selection lines or control lines. The selection lines determine which input is connected to the output. There are many types of marks like 2 cross 1 multiplexer that has one selection line, 4 cross 1 multiplexer that has two selection lines, 8 cross 1 multiplexer that has three selection lines, 16 cross 1 multiplexer that has four selection lines. Uh, Multiplexer is called a data selector because uh, there have selection lines that determines which input is connected to the output. That's why multiplexer is called a data selector. Okay. We have a formula 2 to the power m is equal to n. Here n is number of data input, m is selection lines or control lines. In this slide, they have a picture that shows the diagram of a multiplexer. So let's go to the next slide. Okay. 4 cross 1 multiplexer. There are four data inputs and two selection lines, that is S1, S0, and in the right side, they have a truth table. And finally, a logic expression is given in the value. Okay, let's go to the next slide. Here, the slide shows a circuit diagram of 4 cross 1 multiplexer. Okay, next. The slide shows 8 cross 1 multiplexer. In a 8 cross 1 multiplexer, there are 8 data inputs and 3 selections or control lines. In the right side, there shows a truth table of 8 cross 1 multiplexer. The selection lines S1, S2, S0 select the data input. If they select data inputs 0, 0, 0, the output will be I naught. So in between among of three inputs, there will be the 8 combinations. So in the truth table, there are 8 combinations, and each combination's output is Y. That is I naught, I1, I2, I3, I4, I5, I6, I7. So for an example, the inputs is S2, S1, and S0, 1, 1, 1. The output will be I7. In the below, logic expression is given. So go to the next slide. Okay, the slide shows the circuit diagram of 8 cross 1 multiplexer. Next. Finally, uh, the slide shows the implementation of 8 cross 1 marks by using 4 cross 1 marks. If we implement 8 cross 1 marks, we need 4 cross 1 marks and two 4 cross 1 marks. Okay, we know In a 8 cross 1 marks, there are 8 inputs and 3 selection lines. But 4 cross 1 marks, there have only 2 selection lines, S1, S not. So in the diagram we can see a new selection line, that is E, is connected between two 4 cross 1 multiplexer. When a 4 cross 1 marks is online mode, the another 4 cross 1 marks is offline mode. That's why a NOT gate is connected to the selection line E. Okay, when we connect two 4 cross 1 marks, there will have a 8 cross 1 marks, and the output will be Y. And the circuit diagram works as a 8 cross 1 multiplexer.
So, finally, this is the implementation of 8 cross 1 multiplexer by using two 4 cross 1 multiplexer. We know in 8 cross 1 multiplexer there are 8 inputs. So we can see these are 4 inputs and these are 4 inputs. So total 8 inputs. We can call it I0, I1, I2, I3, I4, I5, I6 and I7. We can see in the implementation a connection between two 4 cross 1 multiplexer by using a NOT gate. When this bit is 0, this 4 cross 1 multiplexer is disabled and this 4 cross 1 multiplexer is enabled. When this bit is 1, this 4 cross 1 multiplexer is enabled and this is disabled. We know between two bits there are 4 combinations. When right now this 4 cross 1 multiplexer is enabled, so this is a combination 0 0. According to the combination, the output will be I naught. So there are another combination 0 1, the output will be I1. There are another combination 1 0, the output will be I2. So there have another combination between two bits 1 1, then the output will be I3. When this bit is 1, this multiplexer is enabled. So this is a combination between two bit 0 0. According to the combination, the output will be I4. When the combination is 0 1, the output will be I5. When the combination is 1 0, the output will be I6. And finally, when the combination is 1 1, the output will be I7. So finally, this implementation is successfully done.
So better quality for watching. Right now, this 4 cross 1 multiplexer is disable and this is enable. So right now, this is enable and this is disable. Thank you.
Thank you. Sir, we have another members named Samuel Islam, the ID 242396040. We did not declare the name in the welcome slide. So we think your consideration about this matter.
So that's all. That was all about our presentation. Uh, Next slide. Uh, Thanks for your valuable time, sir. Keep us in your prayer. We try our best to present the presentation. So thank you, sir.